There's a huge assumption that's built into all of these valuation models, and it's what's called steady state. And it's the idea that growth is going to continue at a certain pace. And reality is that steady state doesn't exist. Companies sometimes grow more than they grow other times, and that's how reality works. That some quarters are better than others in terms of sales. And most companies are not able, there are actually companies, Costco is one company that is legendary for steady state. But most companies are not steady state. And when you think of really big companies, there's a huge risk that they're saturating their market and they're not going to be able to maintain their existing growth rates. Nonetheless, valuation models tend to rely on the steady state assumption, and it's a very dangerous assumption because it can lead to misleadingly optimistic results. So here we came up with an equity value of $99 based on the various models that we've been using. And these do assume steady state. And steady state is a dangerous assumption. So steady state kicks in with your terminal value because you can manipulate growth rates during your horizon period. So it says here the longer the forecast horizon, the lower precision the model. That's true because the further you get into the future, the writing here is a little confusing. But the reality is that the further you get into the future, the less likely that your assumptions and your estimates are going to come true. So whatever you're doing, the further you're going into the future, the more things are likely to change, the more risk that is your assumptions are going to be all wrong. So the total estimated firm value is the sum of everything, and the earlier values tend to weight a little bit more than the later values, but the later values, there's so many of them that they overwhelm your assumption, and therefore they have a disproportionate effect on your outcome. So if that sounds complicated, this is a nice way to look at it. So take a look at the DCF model for a moment, and you can see here that present values tend to go down in the future. So 2017 is going to be weighted a little more than 2018, 2019 because of how present value works. But then your terminal value comes around and it predicts, it's based on everything that's expected to happen in the future, and that creates 86.7% of your estimate. So almost the entire estimate, almost 87% of your estimate is based on this terminal value. And terminal value always assumes steady state. So if you assume 2% growth, you're assuming that this company is going to grow 2% for the next 1,000 years. And that's very problematic. One of the nice things about the ROPE model is that it shifts more value out of the terminal period and into net operating assets. So by adding net operating assets into the valuation, here it's 25%. We still have the horizon period, which are a little less value because they're based on ROPE rather than free cash flow. But what that has the effect of doing is reducing the weight of the terminal value. And the terminal value is really the most dangerous number here because it's so huge. And it's really the least accurate number in your estimate because it's so difficult to get at a realistic terminal value. So ROPE model, for that reason alone, should deliver you a more precise estimate. And again, that's why we would want to extend our horizon period, because the more you can put into your horizon period, then the less value that's going to come out of the terminal period. So these models mathematically give you the same numbers if you have steady state. But steady state assumes that sales are growing at a constant rate. Sales are going to increase 2% a year or 1% a year forever. That NOPAT from each dollar of sales is going to be the same every single year of your during your terminal period. And the NOA needed to generate these sales is not going to change either. And none of these are good assumptions. So it doesn't say it here. But where this wreaks havoc is in the terminal value. Because the terminal value in your horizon period, you can change all this stuff around. And you could assume that you have to increase net operating assets in 2019, and you can add all sorts of little tweaks and fun little things into your spreadsheet. But terminal value is just hardcore. This times this times this times this, that's what's going to happen forever. So this creates a problem in your analysis because it's completely unrealistic. You can't, nothing has steady state long into the future. Sooner or later, everybody dies. And therefore, sooner or later, companies disappear, things happen, they change management, and therefore, whatever you're assuming is going to happen in the future is not likely to happen. The book proposes a way around this, and they show the problem here. What's happening is that because in this model, and this is on page 13 of the book, they're showing you here that the horizon period, everything's in flux, but the problem is that they haven't yet reached steady state in 2021. And I'll tell you that I don't think steady state exists. But this is a growth company where growth is high now, but we're not so sure growth is going to continue long into the future. Yeah, there are lots of examples of these companies where they're growing to a certain scale, and then things are sort of going to slow down when they become more mature companies. And research has shown that this is very common. Not many companies grow and grow and grow and grow until they take over the whole universe. Sooner or later, they're going to slow down and become more mature. It's interesting. Everyone's waiting for this to happen to Apple right now. This is summer of 2018, and who knows if it will. It seems like Apple is just going to grow and grow and grow until they're worth $1 trillion and they take over the universe. Anyway, here you can see that growth is going to continue on into the future. And based on our projections, we come up with certain terminal assumptions to create the terminal value. And here for 2016, it's 16,193 for a free cash flow model. And under the Ropey model, it's 13,015. And the book shows you something that to them is completely jarring. And that is that the value per share is different. Because they're saying that if you have steady state, discounted cash flow model, and the Ropey model should give you the same stock value. But here you don't have steady state by the time they reach the terminal value, and therefore the terminal values are sort of off kilter, and that throws off your stock value. Now, again, what I would argue is that the assumption that you're going to achieve steady state in the terminal year is not a realistic assumption, but let's just go play along with them. And what they show you is that if you can move another year forward and add another year to your horizon period, then you can now get a equal values for your discounted cash flow model and your Ropey model. The real lesson from this analysis, in my opinion, is that the more years you put into your horizon period, the better, especially when you have a growth stock. If you have a growth stock, then you want to be able to predict how long are they going to be able to grow quickly, and then move your terminal period back as far as you can. Because there's a lot of things that are likely to happen in the next 5 years, unlike a mature company where things tend to all go along at the same pace.